All right. Well, here we are.
Is there any
So we're gonna get started. There are only 4 people here this time, but that's all right. I'm okay with that. So last time, I'll wait for you to get all your code up.
I am killing someone for doing this.
Last time we had an oval that went across the screen. We had a little glitchy thing here, and there's a few reasons. First thing we're gonna fix is that little glitchy oval, and that's caused by the screen being updated after the main paint method's been called. It just what we have to do is you see if I move the thing, calling the paint method again by resizing, it gets rid of it. So all we really have to do is fix that. So if we go down to our thing here, you want to go ahead and do graphics.setColor and whatever you want your background to be. So I'm going to do color.black for this. And then we're going to do graphics.fillRect to fill a rectangle. And this is just going to be a rectangle. We're going to paint the back every single time. So it's going to be 0, 0, X, and Y. And then the width of the rectangle is going to be the actual width of the frame. So we can call the getWidth method to get that. And then getHeight, same. Remember, use camel case for this? Okay. These are 2 lines we just added, which I'll just comment it. So this is, where do I get closer? You don't have to sit right here. Okay. Is that color scheme okay? Do you guys want me to try something else, or?
Yeah.
I was gonna say, I didn't think you could do it.
Alright. Let's try this again.
So all we did to fix that problem was just paint the background. And now if I run this program, we're just gonna have a black screen behind the oval, and it won't have. Yes, it's brand new technology. So pretty much we're gonna get a few more boring things out of the way, and then hopefully we'll get into some actual good stuff today. Is everybody up to date with that?
So how long until we go Half-Life 3?
Okay. So just to get some people. Hold on. At some point, this is gonna be our game.
It's RuneScape.
This is not risky.
2000.
Oh, we got tiles.
It's what RuneScape Wood is for.
We got animations. I've also got a tile palette over here. We can actually place tiles down here. So it's actually a liquid, but yeah. So that's what we'll have at some point.
Hey, what was that game?
That was our game that we're going to be making.
The first meeting, a lot more people.
Yeah.
Probably.
Right there.
Well, the thing is, really, I shouldn't have to do that. Anybody that really wants to do this should just.
Are you able to control that?
Oh yeah, we'll be shown in depth. The thing is, we'll get to the point where I don't want to just like make a game with you. I want to teach you guys how to make a game. So we're not gonna actually like you don't have that's not gonna be your game like entirely. You're gonna make your own little thing.
Are you able to walk through the walls? I don't think that's good.
Walk through. Well, yeah, we haven't got collision yet.
Either that, or you can just get the characters to go.
You can't exit out? Did you do the exit on close thing from before?
How do I exit through the terminal?
You don't have to exit the terminal though. You should just exit on close.
And it's wrong now, so it's okay.
To exit the terminal, you can do Control C.
Just crashed it down.
Wait.
All right.
What did we do?
Yeah, I fucked with it.
So we all got that now. We did. Okay. So this is what we just went through. Remember, we have a buffer strategy, which is buffers our graphics pretty much, so we don't just so the user doesn't see us actually drawing to the screen. So that's what the buffer strategy is. And then our canvas is our component that we actually draw all of the graphics to, and it will handle our buffer strategy. So now we're going to get into something else that's we're not going to get too in depth with. We're going to get to the point where we can make something that's like runnable, that we're not running with like a hammer. Like the while loop right now is kind of just sketchy. So we want something that we have a little bit more control of. So that we're gonna get into some threads here. So what a thread is it is an executor of code. So I like to think of it as if you're reading through the code, you are one executor of code. Like if you're just reading code and you're compiling it inside your mind, you are an executor of code. If there's two of you reading code at different places, then you are two different threads. So that's what we got here. And having multiple threads means you have two executors that are concurrently, two or more executors, that are concurrently reading lines of code in order. Yeah, and it gets, the reason we're not going to do too much with threads is because when you get into multi-threads, you get two executors of code. You can imagine what problems you can have if they're executing the same method at the same time, they're accessing the same variables. Bad things can happen sometimes. So we're only going to get slightly into threads. Every program we have made so far in computer science and everything, probably, well, whatever, has only had one thread. I think everything so far we've done in school, and I think in advanced as well, it's just one thread. And to instantiate a thread in Java, we have to pass in a type of runnable. So this is just the actual what Java calls it. This isn't like what every single thread is in the entire world. Java calls a thread, and you must type in a runnable, which the thread will run. So, does that make sense, guys? And we'll get into the Java doc. And that means we have to implement runnable into our game. Now we're going to get into what implement means. Now, this is kind of just going to be a little much, but I'm going to try and get into it quickly. Implement. The implement call is almost the same as extend. So remember, extend was if you had a class and you wanted a class that was almost the same, but you wanted to just add more things to it, you would extend it. Implement is almost the same thing, except it implements something called an interface. An interface is almost exactly the same as an abstract class, except the methods are also abstract. So here we have the animal class, and the animal class has these two methods, except they're completely blank. Yeah, this is interface. Sorry. Yeah. That's the interface animal, and it has two methods that are completely blank, just eat and travel. And they're completely blank. And then over here we have class dog, which implements animal. So it implements that animal interface. And this is actually required to create these methods. If you don't create these methods, you'll actually have an error. You have to use the methods that you used in the interface. So these ones that we created that are completely blank, you do have to put those in the one that you implement. So that's really the main difference between implement and extend. For extend, you don't have to override every single method, but for implement, you have to for the interface. Okay, does that make sense? And you can't just implement any class, you have to implement an interface.
Wait, you have to override every single method.
What?
If you have to override every single method, why do you use interface?
Well, let's say you have a list of animals in an array. This could be any types of animals, but the animals have those methods and they can be accessed through the type animal. So like they don't necessarily have to be an array of dog, an array of cat. You can just have an array of animal, and you can have all of those in that array. It's like the hierarchy. You can have an array of objects in Java, and that array of objects can hold literally anything. So that's really the reason you would do that sort of thing. But you're right. For this example here, it's not required. You can have a dog and just create these methods. It's just then you could not call it an animal. You just have to call it a dog. Oops. So are we all good with that?
So it's basically like a checklist of things that the thing to do.
Yeah, sort of. I mean, the interface has these methods, and if they're not overridden, you'll get an error. You have to override these methods. Are we good? I keep accidentally clicking things. All right. So render and update. Now, what you probably have noticed on some of your computers, the sphere, or the oval, will move a lot quicker on other ones than it does on some. And that's because all computers run at different rates. The supercomputer at MIT will probably run faster than a crappy laptop at this school. So we have to, the reason we're learning about threads is so we can control that kind of stuff. So computers don't run at all the same speed. And we don't want the speed of our game to change based on what computer you're playing it on. Now, when I say speed here, I'm being careful because I do want the game to render as fast as a computer can handle it. But I don't want the actual speed of the game. Like when a character moves around, I don't want them to shoot across the field on one computer and like go snail speed another one. I want it to remain the same, but I also want it to render as fast as it can. There are some games that you might have heard are locked at 30 FPS. Like on Steam, they have the FPS Police collectors group. And any game that's locked at 30 FPS will be put on there. That's kind of the reason why some of those games are locked at 30 FPS. Not the case for all of them, but for some of them it's because they just were lazy and said, well, I want the speed to be the same on every computer. So I'm just gonna make one thing and one method to handle that. But here we have two methods. We have render, which will run as fast as the computer can run it. This method will run literally every single time the computer can handle it to render onto the screen. And then we have update, and this method will run at a very specific rate for every computer. So it's the same for every computer. The only problem that we come into with update is, and we won't get, because our games that we're going to make are going to run at like 400 FPS, because they're not going to be that difficult to run. But let's say our computer, we have the specific rate for the update method, but let's say our computer can't even run that fast. That's the only problem we'll come into with this tactic, is if the update method is actually unable to run that fast on the computer. No. It'll just not run as at the specific rate where we give it. Does that make sense? We have a render method which runs as fast as the computer can handle it, and the update method that will run at a specific rate. And the reason we have this is because we want this to run as fast as every single computer can handle it. So whatever computer you're on, it'll run as fast as that computer can. And the update method, whatever computer you're on, you'll run at the same exact rate. So how we're going to do this? Probably thinking we're going to have to take time into account. This is what the render method does. The method will render everything to the screen. The update method will update player and NPC movement and change any variables, etc. So the update method will pretty much do everything else. The render method will just render everything to the screen. So, any questions? I think last time I lost people, and that was because they weren't really saying anything.
No, you definitely lost people.
Oops. Well, luck couldn't come today as well. But yeah, I don't doubt that I lost some people. But a lot of those people decided they didn't want to do this, so it's okay. Hopefully, yeah, that's where I'm hoping we're getting. We might not though, because it's already 3. But first thing we're going to do is open up our Java doc like we did before. I downloaded the Java doc, so I'm just going to bring that up now. So let's go to, oh my. So I'm going to go ahead and go to Runnable. Because remember, we need to implement Runnable to create to use threads here. So here it says there's an interface, so we have to implement that. And hold on, I blocked it on my screen. Implemented by any class whose instances are intended to be executed by a thread, and specify a method of no argument called run. So that's really the main thing here. We need to have, the only thing that this is going to implement is one method, and that is run. So that's the only thing that we're required to implement when we implement a runnable. So if we go ahead and do that, public class game extends JFrame and implements runnable. And sorry, I need to. We need to import it as well, and that is java.lang.runnable. So let's go over here. Graphics. So import Java. Actually, let's put it up here. Import java.lang.runnable. So we got our import here, and we're implementing it here. Now this will not compile, so I want this compile. We can make a run method. I'm just going to make that. We'll put it down over here. And we can get rid of these comments here. So public void run. And that was exactly what the method was, and I'm pretty sure it was uppercase as well. Nope, it's not. I'm sorry. It's lowercase. Lowercase or uppercase doesn't matter. And it has no parameters. It's just run. It's just a method with absolutely no parameters.
What purpose does run serve?
What?
What purpose does run serve?
Well, we implemented runnable. Runnable is required. We're required to implement one method when we put runnable in there. And the reason we have that is because when we run this, we're creating a thread here. Our game is a thread. So this is our thread here, and we want to actually start this, so the run method will run the thread. So what we're going to actually do is we're going to go up here where we have this real bad loop, and we're going to copy this whole thing down into the run method. I'm going to copy the I stuff as well. And actually we want, yeah, that's it, okay. Sorry, what? As well. Not the create buffer strategy line, just the, just this line. So this should be your run method now. I just copied everything we had before down here. And it should compile now. But when we run it, nothing will happen. Well, frame, but actually, nothing will be here. Because we're not actually calling the run method. But we're not just going to call it. We want this to be a thread. So what we're going to do is go up to our... This up. It's going to open up over there. I'm going to go into our main method, where we actually create the game. We have a new game here. And I'm just going to actually create a variable here for the game. It's going to be game equals new game. So we're storing this we're creating into the variable game, which is lowercase. And the reason I want to store this is because I want to create a thread. We're going to call this thread just game thread. And that's going to be equal to a new thread. And if we go back to where, actually go to the Java doc again. Sorry, don't worry about copying that down right now. I want to show you this first. If we go to where thread is, thread is a thread of execution. A thread is a thread. All right, you got it? Good. All right. It's an execution in a program, and it says that if we go to the, if we scroll down, we don't actually have to read this. We can just scroll down to where the constructor is. Right down here, and if we pass in a runnable, it will run that runnable. If it's just empty, it'll just like allocate a thread that does absolutely nothing, unless you like figure stuff out later, but we're going to pass in an actual runnable. And another thing we want to do is import thread. So that's java.lang.thread. Go up again and add that to our imports. Import. Please let me know if I'm going too fast. We'll go back to that. Well, any class that class names are always going to be uppercase. But the actual name of the variable is going to be lowercase. It's going to be camel case. Do you remember camel case? All right. So we got java.lang.thread. We're importing that. Let's go back down to where we're doing stuff. So we got game thread equals new thread. Is that too small? Maybe I can zoom this in. Yeah. Well, if you're watching the video, sorry for it was way too zoomed in on the video for a while, but I just fixed it. So sorry about that. You should have saw everything now. So we've created the thread, but we're still not starting the thread. So right over here now, we're going to do game thread dot start. And that will just start the thread, and the thread will call the run method. If we go to the Java doc, that is down here. Causes this thread to begin execution. The Java virtual machine calls the run method of this thread. There you go. So that's where I get all my information, from the Java doc. And this, if we were to compile this and then try running it, I have no idea where it went. Did it even run? Did we do something wrong? Okay, let me figure out what we did wrong.
Whenever mine opens up, it's just a blank thing. It doesn't really do anything. It's a blank thing.
I can make both parts of this, and both work.
Hold on a second, I need to figure out, I don't know where this extends, if you're in trouble.
Yeah.
I'm just gonna get the one that over and try to get
Creating a buffer strategy.
this directly isn't in the room anymore. No, that's, well, to me, we can get this room inside this room.
He's doing good, right?
He's there. Let's see if this is even getting here. Here's some debugging. I have no idea why it's happening, but we're going to go ahead and see. I'm here. We're going to print that. You don't have to actually do this. I'm just going to show you what would happen. Did it print something? I don't think it did. Okay, so it's not getting here, which means the run method isn't being called, which means implements runnable, extends JFrame, creating a game. Oh, yeah, sorry. Yeah, we have to pass in the, I thought I had it because I was looking at the wrong code. We need to pass in game. Because I actually just said that if you have an empty constructor for thread, it will do nothing. And guess what it did? There you go.
The last question. All of the stuff that we put inside Rust, where that outside from?
All the stuff we put inside.
Alright, all the stuff that we put inside Rust, do we think that that's outside of Rust? Yeah, I got it. Get rid of that. Why use a WordPad? Because this is a computer.
You still fix it?
Oh, no.
You need to pass in. See if you've read. No, pass in the game, but it's actually Marcus that's this down in side. Yeah. Start like that. There it goes. Oh, it's on. Anyway, he has that down side of run. Yeah. No, like. Oh, Marcus is the glasses. No, it's right in front of the
I'm-
Those are beautiful 3 FPS. Okay. Does that run? That's incredible.
Exactly.
What?
Well, the code will be online as well, so if you can't run this, you can check later.
Okay.
Code online. But yeah, we moved pretty much everything we had that was up here. Everything below the sorry, I'm looking at it. Everything below this line, we just cut over to the run method. So the starting with the buffer strategy equals canvas.get buffer strategy line, we went down and put all this in there.
So how do you pass game into the game game inside of the call?
What do we do? What are you saying? This is what we're doing instead. We're passing, because thread has a parameter, has a constructor with a parameter that takes a runnable. Game is a type of runnable, so we pass that in. And that actually calls it to an outrun. So that's interesting. So we're going to try this next thing in if we can. I hate that it opens over there every single time. That's So I'm going to go back to the presentation quick so we can remind ourselves of what we're doing now. Well, first of all, does everything we just did work for everyone? You just can't.
Still stuck in it. Oh God. Oh Lord. Oh Lord.
If you go up to the,
I think it just has something to do with that the computer sucks. So people will have to read questions. I don't know what to do. That's hilarious.
You're going to have to abandon ship.
It's gone. Hey Mark, it's almost good again.
Alright, just give me about 30 minutes to research.
It's terrible.
Well, we can just stop here. For next time, we're going to be making these two methods, and we're going to be using time to make the update method, and render is just going to happen as often as possible. There's no import to render and update. We're actually creating those methods. Yeah, we're actually creating stuff now instead of just working with libraries. Yeah, I think I scared people off because we were just working with random stuff that, like I was honestly, because the Java graphics library that they have is just a giant beast. So I wanted to just quickly get through all that stuff. So we have something we can just work with.
You need to impress us. We're easily distracted.
Yeah,
Is it possible to code Xenoblade Chronicles in Java?
I have no idea what that is.
You've never heard of Xenoblade Chronicles?
No, I haven't.
You've never heard of Xenoblade Chronicles?
All I got is a video game. Past that.
Probably a video game.
No, I've heard of it.
Heard of it?
It was only released in Russian.
That's why.
Probably why we haven't heard of it.
I got a copy today.
So yeah, if you borrowed a computer from Mr. Upley, if we're gonna get, and I'll be honest, if we're gonna get like, we'll see what happens next time. It could have been because I didn't really announce it too much. But if we're gonna get,
During lunch, you said, "Oh, hey, Alex, you're coming, all right?" Sure.
I announced it in the computer science classes, a little bit. But if we're gonna get like 4 people, I might just make this a video thing. So we'll see. But
I had better things to do, like solitaire.
I have nothing better.
Here the answer is say, "Hello, Marcus's room."
it's nice.
Hello, this is Marcus. He's in the meeting right now. Okay. No problems. Alright.
I think I love it.
Okay. Well. Sorry we didn't get much done.
Okay.
Well, we get thread stuff going. I don't know. Slow but steady. See you guys.
Like by the end.